In this video, we will show how to assign function to layers in a wall type and position the core boundary layers to control the cleanup between walls when they are joined in the model. We will also show how to stop walls from joining when the junction is not required. The position of the core boundary within the wall assembly and the function assigned to the wall layers determines how walls will clean up when they join in the model. All layers positioned between the core boundaries will always continue through to meet the layers within the core boundary of the wall that they are joined with. Layers outside the core boundary will be cut to allow this to happen. Therefore, the positioning of the core boundary is an important factor in achieving the required junction between walls. The layers are also assigned a function and priority which will influence the cleanup too. There are 5 functions with their associated priority shown in parentheses, with priority 1 being the most important and therefore priority 5 being the least important. The function indicates what the layer may be used for, but when walls join, it is the priority which controls the cleanup. I have the exercise file wall joins open, and looking at the wall detail floor plan, we'll use zoom region to zoom into the office at the top of the floor plan. And we can see that we have a partition coming up to meet the exterior wall. It's showing us the metal stud layer of this partition going through the wallboard and the furring to meet the CMU layer of the external wall. And this junction works fine and is what we would expect. On the outside of the wall, there is a section of wall that has the same granite panel finish on metal stud, and this will be used for a screen wall, so it doesn't require the same structural or thermal properties as the main external wall. This wall does have to join the external wall though, so I'll select it, and using the control at the end of the wall, we'll drag this over the external wall, and it doesn't really matter where, as Revit would join the two walls according to the settings in the type properties. And we can see the junction that it's created here. It shows the metal stud and the air layers of the screen wall coming right through to meet the CMU layer of the main external wall and cutting through the insulation layer in the process. So let's look at how Revit is forming this junction. In this image, we can see the junction that we currently have, which is the metal stud and air layers of the screen wall cutting through the insulation to meet the CMU layer of the main external wall. The junction required is for the metal stud layer to meet the edge of the insulation in the external wall and for the thermal air layers of both walls to merge. Currently, the main external wall has its core boundaries positioned around just the CMU layer, and in the screen wall they're positioned around both the metal stud and air layers. And hence, the layers contained in the core boundary are cutting through all of the layers outside the core boundary to meet each other and form the junction. We will need to move the core boundaries to incorporate the layers that we want to control in the junction, so for the screen wall they need to be moved in to contain just the metal stud layer, and for the main external wall they need to move out to incorporate the insulation layer too. But if we just move the core boundaries, we will still end up with the wrong junction as illustrated here, and this is because the priority of the layers also needs to be altered to give us the junction that we're looking for. This means changing the insulation in the main wall to be a substrate with a priority of 2. In the screen wall, the air gap layers must change from substrate to thermal air with a priority of 3, and the metal stud layer must change from structure with a priority of 1 to be a substrate with a priority of 2. And this will give us the junction that we require as we see here. So I'll swap back to Revit now and we'll see how to do this live in the model. First, I'll select the screen wall coming down from the top of the view, and then from the properties palette we'll choose Edit Type to access its type properties. Then we'll click Edit next to the structure parameter to access the wall assembly. Looking at the layer list, we can see the core boundaries either side of the air layers and incorporating the metal stud layer. The air layers need to be moved outside of the core boundary, so I'll start by selecting the top air layer, layer 3, and then click the Up button to move it above the core boundary. Then we'll select layer 5 the lower air layer and click the down button to move this one outside of the core boundary. And we can see in the preview now the green lines indicating the location of the core boundaries either side of the metal stud layer. While we're in the wall assembly, let's change the function and priority of the air and metal stud layers. We'll start by changing the upper air layer, layer 2, from substrate to thermal air layers with a priority of 3. We'll repeat this for layer 6, the lower air layer. And then for the metal stud layer, which is layer 4, this is currently set to structure with a priority of 1, and we'll change it to substrate, which has a priority of 2. Now we'll click OK to save those changes, and OK once more to apply them to the walls in the model. So now we can see that's changed the junction, but we need to edit the insulation in the main external wall to complete the junction. So we'll select this main wall, and again we'll choose Edit Type from the Properties palette to access its type properties. And then click Edit next to the structure parameter to access the assembly settings again. So here we can see the insulation layer is outside of the core boundary, but needs to be within those core boundaries to give us the correct junction. So this time I'll select the upper core boundary layer, which is layer 4, and click the up button to move it above the insulation. And now we can see it's within the core boundary along with the CMU layer. So now we just need to change the function of the insulation layer, and we'll change this from being thermal air layer with a priority of 3 to a substrate with priority of 2. So this should now give us the junction that we need, so we'll click OK to save those changes, and OK to apply them to the walls in the model. And now we can see we have the junction that we wanted, with the metal stud layer of the screen wall meeting the insulation layer, and with the air layers of both walls having merged to be a continuous component around the junction. An alternative scenario would be if the screen wall was built after the external wall, and therefore we didn't want the components in the core boundaries to interact or to create any kind of join between the walls, and we just wanted the screen wall to finish against the granite panel of the existing external wall. So to achieve this, we would need to stop the walls from creating a joint. To show how to do this, I'll select the current screen wall that's got the join, and we'll make a copy of it. So from the Modify ribbon tab, we'll choose Copy, and then click to pick the wall up, and we'll move it across to the left here, and then click to place it down. I choose Modify to finish the copy command, and we can see that it created the same junction as it had done previously. So to stop this from happening, we'll select the wall, and then hover over the grip at the bottom of the wall where the junction is made, and then from the right click menu, choose Disallow Join. Now when we deselect the wall, we can see that they no longer join, and the screen wall is just overlapping the existing external wall with no attempt being made to create any junction. If I reselect the screen wall, we can see at the end of the wall we'll have the symbol here to indicate that the joint is disallowed for this end of the wall, and we could click this symbol to re-allow the join. However, we just need to cut the screen wall back to meet the external wall. So to do this, from the Modify ribbon tab and the Modify panel, I'll choose Trim Extend Single Element, and then select the edge of the external wall to be the boundary, and then we'll choose the side of the screen wall that we want to keep. And now we can see that we have that just butted up to the external wall without any junction being made. So there we can see how the core boundary and the function and priority can affect the cleanup of walls, and how different walls can meet to create different detailed junctions.